All right, great. So let's go directly into my okay, special system owners. Here's what we're going to go over, guys, and I hope you will some of this will be good review for all of you. If I can have your attention, thumbs up, Chad, we're with you. And the donuts and the apples are working good. Energy, no? Okay, a couple of things, guys, I would like to go over as lighting control. We're gonna get sick about Chad and everybody else talk about lighting control. There's a couple of concepts in this chapter about lighting control. It goes as simple as snap switch on the wall, or circuit breaker that the light is going to be on all the time, or having timers or occupancy sensors. So a few things about lights. The second thing I want to talk about is boiler room, how to size a boiler room. I'll show you a couple of pictures and where to size the information for the boiler room. Sump pump. What do you need to know a little bit about sump pump? You guys remember we did sump pump in residential? Sump pump. So we have lights, we have boilers, we have sump pumps. And a few things, guys, about the elevators. So a few things that we're going to talk about the elevator. Okay? Sorry. That's all right. So we're going to talk about the elevator. I'm going to tell you a few things about the elevator in this room. Again, the heating and cooling and the standby power systems that we'll be talking about in a second. Okay, lighting circuits. One very simple thing. I'll show you a couple of pictures, guys. For lighting circuits, if you right above your head, Nick, you can have the light on at all times. Because of environmentally friendly, it's not an option now. So usually you have to have some type of auto control in a commercial building. When you say continuous light, you just put the light on a circuit breaker, Ashley, and you don't switch it. That's what continuous load is. Continuous light. Second thing is manual control. Where's manual control? Right here. Turning this on and off. That's manual control. That's the poor man/woman job. Third one is auto control. Auto control, you can have a timer or astronomical clock. You can use it on parking lots. That, like we did, you put a timer, you time it from certain time to certain time to go on and off with the astronomical clock. Also, we can use timers. Photocell is commonly used. Also, you can use it in the outdoor, the parking lot. And the last one is, how do you wire the exit signs? Chris, you have done it. Did we switch the exit signs? No, so that will be direct, no wiring. So this is just a quick review, guys, of how to control a lighting circuit. I know we use the following. We use manual switches. We did not use continuous. I know we use timers, and I know we use exit signs. We did not switch them. Photocell, did we use photocell or timers? Did you guys use in the parking lot photocell? We threw it on the timer. But also in the parking lot, you can throw a photocell. We didn't use the photocell. Or you can have astronomical clock that follows, do they do by satellite now, Chris? That follows the satellite and adjusts based on your settings. Any question about this? That's what this chapter talks about, the control system in the particular room. Okay, so it talks about here, guys. I'm not going to go over it, where they put all these controls, continuous operation. In this project, remember, this is a project. They did the continuous operation in the corridors. They want the corridors to be on at all times. Halberg used to do that for security and safety and all this good stuff. The same thing, those guys, they did the corridors, stairways, they put them on at all times. The hallways, they put them on manual switches, as well as the utility rooms and toilets. We put our toilets on what? Occupancy sensor. So auto control, they have some auto control. I don't know why they mix the sump pump with it here. Timed timers, they put the timers on owner commercial building, basically the perimeter lights and the parking lot lights for them. I'll show you. I want to go directly into the picture, guys, in a second here. Photocell. I'll talk about the exit signs. We talked about exit signs, guys. You have installed it. Exit signs have a battery on them. You always power the exit signs from the circuit that feeds that particular area from the line side of the switch, not the load side. And you guys have done it with me, no switching for them. Talk about the sump pump and the circulation in a second. And talk about these water heaters. We'll talk about this and elevator. I'll get back to the elevator in a second. Okay, so I'm flying through these because I really want to go to the pictures. Okay, so here's what I like pictures better than the talk, right? Pictures. Okay, here's a few things, guys, that you need to know. If you have a light or a fan, in this case, a bunch of lights, you can have optional standby panel board, clock for motors or something. So here's a control, a time, my time, time control contact. So you have a timer, and the timer will time out and close this contact at a certain time. All these lights will go on, and another time they go off. So how do you wire this? You bring a circuit, 20 amp circuit, and you will have the timer. This is my timer. This is line timer, they call it. You put the line timer over here. And when you put the line timer, guys, there will be a coil. Energize the coil based on the timing that you do. Close this contact. These lights will go on. These lights will go on. And they're showing the clock that drives the motor right here, coming from optional standby system. Option standby system. Most of the timers, guys, that we use right now is well, if you don't have a panel, you have a timer, a line, what they call it, line timer. You bring the power into it, input and output. You can get as many outputs out of it as you can, as you need. So really, in reality, when you wire these, the only thing you need to do is you bring a circuit from here in, and the neutral out. Here's my phase A, here's my neutral. This is my timer. Out, you go to your lights, right? And this is my line. Inside the timer, there will be a contact that controls the hot most of the time. And there will be relays and programming and all the stuff. I dare to do something like this, probably a control that drives this contact with a lot of settings here. So this is my coil. You energize the coil, and there's again a lot of settings here to control the coil right in this area. When the coil is energized, it drives that contact shut, and the light will go on. When the coil is not energized, when you de-energize the coil with electronic timers or mechanical timers, you de-energize the coil, that will open. Any comments, any questions, without getting into the details of how timers work and so forth? In our panel, we have a timer. The timers that you guys have, all what you have to worry about is bringing the power in and out of that timer to feed your equipment. Any comments, any questions? So that's my timer. Photocell, here's a nice, and I know we talked, and the guy next on Monday, guys, will come and talk also about Photocell interface. If you have a Photocell interface, all what you have is, you have three pieces. Here's my panel. This is my panel. This is my light, obviously, another piece. My relay, or my relay is here, relay, and this is my occupancy, my photocell. How many pieces I have? 4 different physical mechanical pieces. 4 different physical mechanical pieces. You wire them. You bring the hot. Can you guys see how we bring the hot to the relay and the neutral? So this is in the hot and the neutral. This is what you have to power the. What they're not showing here, actually, my friend, they're not showing the brain of the relay and all this good stuff. And they have an occupancy sensor, photocell, that when this is energized, it'll close this contact, and when this contact is closed, what's going to happen to your light? Go on. Now, the nice thing about the photocell is you can put the photocell in one. Most of the time, guys, they put a photocell on one corner of the building. They wire the photocell back into the relay package to interface it with the relay, and you bring your power circuit directly into the relay, and from that relay down into your lights. So all these could be your parking lot lights. Each one of these could be your parking lot lights. Most of occupancy sensor, and if you guys research, I don't want to go there, they have multiple contacts. Multiple contacts. I can drive from one photocell multiple circuits. How do you do that? So you can buy them with another contact here. I don't know if you can see that, and bring another circuit here, and for another set of lights. See what I do? And then you can use a multi-wire branch circuit, as a matter of fact, and steal the neutral from here. So you can put them in 2 different contacts, especially if they're 2 different circuits. You can put them in 3 different contacts. When would you put them in a different contact? If you have two circuits, if you have one circuit, doesn't make sense to put them in two different contacts. If you have two circuits, you cannot put phase A and phase B timed together and put them in one contact. What's going to happen, Nick? Short circuit. So that's the application. We have multiple contacts driven by the same occupancy sensor or relay. Multiple contacts. So you can lend it. The only way, so you can have three contacts. Here's another circuit coming over here, another 20 amp circuit, still the neutral again, for another set of lights, and so forth. Yes, sir.
What's in the photocell itself that is there another set of contacts that releases or something?
Oh boy.
Because I'm just
Yeah. How it's constructed, how does it sense? Now you're getting into what they call them pilot devices. How do they work? As far as I'm concerned, this is, can you keep this one for the guy, the expert who's coming about all these things? I'm a design engineer. As far as I'm concerned, I have a device. That device is working either 120 or 24 volt. That's all I care. Now what it does inside, I think they have a chamber, and right, they have a chamber, and with the light.
Photovoltaic cell, when light strikes it, energy DC is produced. The DC powers the relay. There's some amplification that goes on. The DC powers the relay.
Okay, so it's working the photovoltaic concept. If it hits by light, if it's for that makes sense. Photovoltaic. If it hits the light, it generate current DC that's amplified to energize the system. Good point. There's so many of them though. There's also the occupancy sensor that works in a different concept, the ionization. So I think you're right. In this one, probably it's the photocell because it's looking for light. It's not motion. It's looking for light. So if it hits the light, hits it, it generates DC voltage, amplify it to get the concept. So Nick, I would like you to keep the hard questions, how the system, how the equipment work for the smarter than chair. But all what I care about is this one. It's going to see a light. It's going to be activated. When it's activated, it's going to close the contact. So my light will go on.
What is it seeing?
A good light.
No, the DC voltage.
Photovoltaic always DC. When you generate photovoltaic,
On that side.
when you generate with the sensing mechanism.
The sensing stuff.
The sensing mechanism is DC. Yeah, I don't know.
But we're bringing AC to it. And then it's
I would say I think so. It's not always true. It's really not always true. The way we're showing it here, we are bringing AC to power the brain, the sensing brain. Yeah, we're bringing AC to power the sensing brain, if that makes sense.
I had to stump it once.
Yeah, I know. You can stump me many times. So, but I'll let me search that one. I can search that one, guys. They have a lot of equipment about them. So anyway, but the key point is it senses, it energizes. Okay, moving into another one, sump pump. Sump pump, you guys, we've done it in a residential. For the sump pump, this is a motor actually, so it's going to give in horsepower. Let's just say it's 1 horsepower. All what I care about for sump pump is conductors, 1.25 times full load current. You guys designed that for Chad. You also need, for the most part, 1.15 times full load amp for the overconduction device. The disconnect, you need 1.15 times full load current. And what else? And controller, you need a controller. This is my controller. And you're done. Typical motors. Conductors 1.25 size, overconduction device. Yeah, overconduction device, if it's fused, 1.75 times full load current. That's it. How does the system work? There's the floating switch, guys. If that little hole in the ground that's full of water, if it reach a certain limit, it will physically mechanically push this ball to physically mechanically close the contact. When it closes the contact, it starts pumping the water. When the water goes down, that little thing, ball, physically, mechanically goes down and open the contact. So what do you have here? You have, for the most part, you have the panel. This is coming from your panel. This one is controller, standalone box. and this one most likely these are in the same place somehow, and it's inside the it, most likely, or at least this piece is inside the it, the measuring piece.
So for this exercise, the fuse, the motor controller fuse is protecting the conductor, correct?
The fuse is protecting the conductor, is protecting the controller, and is protecting the pump.
I'm just looking at the OCPD.
Yep.
Current
Yes.
capacity in the conductor, the
Yeah.
fuse is protected.
Yes. Yes. Any question, guys, about typical pump? They have a sump pump in the project, and that's how you wire it. The most important thing is the controller. Nick, if you want to know about, they call them pilot devices, how many pilot devices they created to control things, and what volts, some of them are electronic pilot devices, others are mechanical pilot devices, seconds are high voltage pilot devices. Each one of these is called a pilot device. Yeah, it's a whole different industry, control. This is the whole different industry. So what most of the time, being electrical engineers, guys, and designers, we're in the construction business. Our focus for the most part is on what I draw. The rest is a whole different field. There's a completely whole different field, which is we can do. It's not rocket science, but you really have to study a few things about they call them pilot devices, and how to interface these pilot devices with the magnetic starters. Okay, so that's my sump pump. I'm going to keep going, guys, into circulating pump. This is really, and again, I'm jumping onto these because I think these are the most important ones. I'll show you the floating switch in a second. There's a picture in your book. The sump pump, my friends, is this one is my circulating pump. I'm gonna take you, I think, to understand this fully. Look at this. In the building, this is really interesting. If you guys do a strip malls, because the project that I give you here is not going to teach you, none of our project will teach you how to do a strip mall, to tell you the truth, because we have them standalone building owned by the same occupant. This project that we have in this book is really nice example of a strip mall that has different tenants, or a building that have different tenants. So look what they did, guys. If you look at this is their heating cooling system. This is their heating system. What they did for their heating system is they have an emergency panel. This is a panel supplied by generator. So this is actually, I believe what they did is they have an auto transfer switch, and one coming from main panel, and another one coming from the generator. That's what they did here. They're not showing. This is gen. Okay. So you have a main panel, that's where your power coming from the Excel, and generator going to an auto transfer switch that's going to transfer you between these two sources. So normally, look what happened. Under normal condition, the auto transfer switch is switching, you're feeding this panel from the utility, right? Under normal condition. You lose power, there's battery in the auto transfer switch that sends the signal to Mr. Generator to come to speed, energize, start. The engine of the generator start it, auto starts. And if it's an emergency, this is an emergency generator. If it's an emergency generator, the whole start and synchronize and come up to speed within 10 seconds. Now it will switch you into the generator, so all your heating cooling system will be backed up. If you lose power, basically you don't lose heat. Look what they do. Each tenant, and I think we have 5 tenants in that project. Each tenant has his own climate control or environment control or temperature control, each one of these tenants. So imagine with a circulating pump. So the way they do it, guys, the water is coming in here, this is water, and going back into the boiler. What they're showing is the boiler is not showing. This is boiler, so the water, look at that, we're boiling water here, hot. The water, when I need, if this is the insurance office, let's say this was insurance office in our building, when insurance office call for heat, right? What they do is the thermostat here call for heat. There's it will close the contact here, right in here, there's a contact. It closes it. That contact is tied to to the controller. The controller will turn this pump on, so it starts circulating the hot water into the system. start circulating the hot water back into the insurance office. When you bring the water to the insurance office, I think what they're doing there is they put it in a machine and they blow air through these coils. So the water is going through a circulating coil like this. You throw the water, you have a blower that you blow the air right through these coils. What do you get from the other end? Heat, in this case. Okay, so can you guys see a thermostat, relay, thermostat, relay, thermostat, relay? So by doing that, you have control for every place. That's a zone. They have how many zones? They have 5 zones. Can you guys see when you talk about zone control? These zones can be at Dunwoody. By the way, they don't have to be different buildings. At Dunwoody, you can have multiple circulating pump that go into different chillers, and you can. And I don't want to get into the control. And you can control different environments, different parts of the building at different temperatures. Can I guys get you to understand that each one of these have a thermostat that senses the heat? When it energizes, closes the contact, the coil here, you're going to see the schematic of this system. And then the pump will start running. Can I get you to understand that this is a wireway? Ashley, you guys use the wireways. This is a great application of a wireway, a great application. Remember we talked about wireways and raceways and surface-mounted raceways. Here's a great application of a wireway because you can bring the power in here. All your conductors are coming. Each pump is going to have its own. I don't know if you guys can see that. Each pump is going to have its own. How many? 1, 2, 3, 4, 5, and they're all going to go right through this wireway, and they're all going to go to their respected. After they are switched here. And come back, switched, come back, switched, come back, switched, come back, and also they're going to be switched, come back. Yep, there's a relay there. You're going to switch them, right, and bring them back down to the system. And they're going to go from here. I'm going to show just one. You're going to go over here. You're going to have an overload here to protect it, and all the way to the motor. Now you're dumping power across the motor. Your pump is up and running. Yes, sir.
In that wireway, would it be a termination box?
I don't think you would need. You could, but I don't think you need anything here because each one of these is a standalone circuit. Each one of these pumps is a 3-phase or single-phase pump with its own power. So all what you're doing, if I'm to describe it, you bring a hot here, here's 20 amp, and a neutral. You take it all the way to the contact here, up. You bring it down, and it goes all the way by itself to the pump. See how it's going?
So there's no splice.
No, you don't need to. You could, but you don't need to. You really, because you land one here. This will go directly. I guess you could splice that if you want to, but you don't need to. You most likely wouldn't splice it.
Okay. Then for the ATS now, so we have power and everything's good. And where's the utility? Can you just draw where the utilities?
The utility is coming. Good point. The utility. Let me use that. The utility is coming right in here.
Okay.
This is the utility is coming to the main panel in this example. And the main panel is taking a feeder to feed the auto transfer switch. To actually feed this panel through the auto transfer switch.
And then when that connection is lost, we do automatic transfer switch.
Yep.
Something electronically.
They have batteries on them. What they do with the auto transfer switch has a battery, sensing battery in it. You lose power. Say we lost the power, gone, dead. There is a sensing mechanism right here that senses the power has been lost coming from the main panel. The first thing, because we have DC to sense it. When we sense there's no power here, there's a control wire that goes to the generator, the engine, the engine of the generator, engine part, to the governor. And that basically close the contact on the engine. When you close the contact on the engine, you have just started your engine. But what I'm not showing is there's a lot of control between the auto transfer switch. There is a control conduit that goes auto transfer switch to generator. Good point. Any question, guys, about this environmental control? I want to show you. So if you look at, remember what we drew here, guys. Then I'm going to take you back to how this looks. This is how it looks. Circulating pump, thermostat. You guys, the schematic for it, Nick, this is your pump in one location, and we have relay contacts, and we have the relay, relay contacts, and relay. Oh boy, I don't know how if these most likely would be in one. Okay, this is my disconnect, right? It needs a disconnect. That's my disconnect and overload. These two are associated with each other. That's my relay. And this is my thermostat. It's they call it line thermostat. So if you sense line thermostat, means high voltage thermostat, not like the one that we use typically in homes. Line thermostat, when it senses, it closes here. Now actually, if this is closed, what's going to happen to the relay? The relay is going to be energized. When this relay is energized, what's going to happen to this contact closes, then your pump is up and running. Your pump is up and running. So this, what you see here, is one out of these 5 pumps that circulating pumps that we have. I promise you guys, we'll go to the industrial project. We have, we talk about, I don't know how many of you know the interface between chillers, boilers, air handling units, and from a mechanical point of view, how do these all mix together? We'll talk about this from a mechanical point of view. Any questions about this? Now don't forget that they have your fuse here. This is your panel coming from the emergency panel, so-called emergency panel. Okay. So that's my control for the circulating pump for this system. Now speaking of the circulating pump boiler, boiler. Now, who's going to be boiling the water? Remember how the system is going to circulate hot water to get heat. Who's going to be boiling the water? We're going to have a boiler to boil the water. When the way they boil the water, guys, they have, here's a 3-phase boiler. I don't know how many of you have seen heating element. This is an electric boiler. The one that we have actually down with Mr. Koljik, it's a gas boiler. You wouldn't see this down there. We have a gas boiler where we burn gas. Here, we're burning electricity. I don't know if they use them a lot in Minnesota, mostly gas because of, cheaper. Okay, so what they do is they have heating element. Heating, you know what a heater is, guys. You put electricity across a resistor, it glows and make heat, obviously create heat. They have them, I want to emphasize a few things here. Each one of this, can you guys see a relay here? Each one of these is controlled. Every one of these segments is controlled individually. Inside now, everything that you see right here is inside the boiler, and we have actually no control over it. It comes as one big assembly. So just to warn you, when you buy it, you're going to buy all this one big fat assembly by the manufacturer, and we have no control over what's inside it. It's engineered, manufactured. But look how smart they are. They can put contactor on every set of resistors that's going to be heating, the heating element. So by doing it that, they can get more heat or less heat from the same boiler. Do you guys agree with me? If I close more of these, bam, 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 every time I close one of these, what am I doing? I'm actually adding more heat. If I need more heat, I close more of these. And these I have their own controllers, sequential controllers. I close them and open them based on the demand. Do I need more hot water or less hot water? So your Johnson controller that you're going to buy is going to be controlling all these, or any other controlling all these contacts. So more heat, close more contacts. Less heat, open more contacts. Does that make sense, guys? The contactor. Now, because nothing lives forever and everything is going to fail, look how smart they are. They also have a fused element. Can you guys see that? These are all fuses, internal fuses. So, Chris, if this is to grab on you and short and damaged and do all hell break loose in it, instead of taking down a boiler that heat all of done with the College of Technology, and then Rob said we're paying a lot of money and we don't have heat, what they do is only one element will be out of business. By doing it this way, guys, and it will give you a warning. By doing it this way, it saves a lot of headaches. One element is died, the boiler is still running. It puts you on your schedule to go maintain it and fix it, but it's not going to take the whole boiler off. Any questions about this? Can you guys see how they take 3 phases at the top? For this project, it's an 800 amp, and it's a 2 sets of 500. They're bringing 2 sets of 500. 2 sets of 500. Now, Chris, I think, I don't know if I have the second page for how to size them for these boilers. Yeah, a few things how to size the boiler. This is very interesting. Just write these if you don't want to write anything, guys. The article that talks about it actually is Article 424. These are the heating elements. A lot of the stuff that I'm writing here is from Article 424, right? When you size the conductors for this, you're going to size the conductors 1.25 times full load current. How do you get a full load current? Times full load current. You get the kVA of the boiler, and you get the full load current from it. So here's the full load current equal kW divided by 1.73 times the voltage, whatever voltage you're using. So from the rating of the heater, you can find the full load current. This one, I believe, can you guys see the rating here? Everybody can see what the rating of this boy is, 200 kW. So you take the 200 kW, you divide it by the voltage, they're burning it at, here's the rating of this boiler, this particular one. We have at 200 kW, it's burned at 208, and it's a three-phase. Is there any neutral net? Do you see any neutral with this? There is no need neutral. They burn them line to line. Okay, so this is how you size the. This is how you size, my friends, the conductors. Now you need ahead of it, guys. You need an overcurrent protection device, right, Chris? You need overcurrent protection device tied together. So this one, the same thing, 1.25 times full load current. 1.25 times full load current. We also need a disconnect. These also need a disconnect within sight, a disconnect. Okay, we're not showing a disconnect. So if I have to show it here, guys, most likely it will be an overcurrent protection device, a disconnect here, and right here boiler. Okay, so when you get into the disconnect here, this one is going to be, as I said, 1.25 times full load current. Disconnect 1.25 times full load current. Conductor 1.25 times full load current. Everything is 1.25 times full load current for the heater. Done. So that's how you do a commercial. This is a commercial heater, three-phase commercial heater with heating elements. Any question? That's all what we need. Now, what's my requirement, Phil? When they come to me, what do they want us to do? Everything inside the red box that I drew is not your responsibility. You bring a cable to it, a disconnect next to it within sight, or being capable of locked in the open position somewhere else, and a fuse or a circuit breaker. Done. How do you bring the fuse or circuit breaker, the disconnect, and the cable? How do you size them? You can see it right in there. Any question, guys, about the heater? What do the heater do? How do they work? Did you guys visit Dunwoody here, down where our heating, the gas heater that we have?
No.
Maybe we should do a tour there. We don't have an electrical heater, but Mr. Koljik will walk you through how we heat, how we burn gas, and how we heat the water, and we'll show you all these circulating pumps that circulate the pump all the way to the air handling unit. Shall we do that one time? You know what? Maybe I'll one of the days I'm not here. Yeah, that would be a good. Okay, let me think about that. Any question, guys, about this? See how easy that is? That's your heater. I'm going to grab my heater, everything I need about my heater. Okay, a couple of contacts and timers. This one is relay NEMA 1 enclosure. I don't know if you guys, you've seen relays in ours. I want to just blow this one on and see, you can see the contacts that comes with it here, the normally open contacts. 1, 2, 3. So 3 contacts. What does that mean? I can drive 3-phase out of that. If I have 3 contacts, separate contacts, I drive a 3-phase out of it. And the rest of them will be where the coil is going to be located and so forth. If it's rated for that, though. Okay, so let's go back into, I think we're here. All right, so we got that one. Nick, this is your floating switch. Obviously, you're not going to bring the power into that water. And I don't want to talk about the pilot devices, guys. It fills up with water. It moves, I think it moves that ball up. When that balls off, there's somewhere contact here that will close that contact mechanical. These are called pilot devices. Close two contacts. Now you energize the sump pump. Any comments, any questions, guys? And again, my intention is not to do control. We can, but not today. The intention. Okay, pilot, outside thermostat, the pump. Okay, so that's what I want to say. The only thing I want to mention, the last thing I want to mention is elevator. I don't think I said anything about the elevator. So could you please do me a favor? And then I'll let you. Okay, a couple of things about the in this project, guys. We have an elevator. The elevator is as a pump. So when you size for elevator, you size exactly, guys, exactly like a motor, right? You take 1.75 for a fuse, 1.25 for the conductors. A few things, guys. We're feeding it from the owner panel. The article that talks about the elevator at this point, and I'm not going to make an elevator class, is Article 620. Here's what you need to know. You need a disconnect means for the elevator. So here's my elevator, overcome protection device coming here. Here's my disconnect. I have to have a fuse disconnect. And here's my pump for my elevator. Here's my fuse disconnect. And here's my overcome protection device. How do you size it? This is Mr. L, elevator. You're going to size this one, guys, 2.5 times full load current. Conductor, 1.25 times full load current. Disconnect. How do you size disconnect? 1.15 times full load current. Fuse overload here, 1.75 times full load current. And there's a big thing here that we're not showing for the elevator is controller. Elevators have their own controller, guys. Don't even mess around with them. So this is really what you need to be aware when you have an elevator, is provide a disconnect within sight of the elevator, a fuse disconnect. They always ask for a fuse disconnect within sight of the elevator.
Is the conductor turned up for continuous for this?
Yes, yeah, all of them, yeah, like absolutely. A pump, motor. Yeah, it's a pump. They treat it exactly like a pump. Actually, the article, if you go to the article 620, they tell you multiply by 1.25. The article that talks about it is right here, my friends. A couple of things also you need to know about the elevator, guys. Lighting and fan and within. Also, the elevator, the car, Phil, the car of the elevator, they bring a circuit to feed the light and the fan in the car, the elevator car. So in Minnesota, I don't know if it's other places, and I didn't install a whole lot of elevator. They require you to have an elevator panel, guys, a panel inside the elevator room. Where inside this panel, there will be the fuse disconnect for the pump, and there will be a bunch of other things, like circuits to feed the car, the elevator car, as well as a circuit. Need a couple of circuits. So there's one circuit here for the light, and they also require a circuit for the pit. Electrical boilers, okay. Another thing that you need to be aware is, actually, inside the pit, we're at the bottom here of the elevator, they want you to put a receptacle here and a light. So we have to have a receptacle. This is GFCI, bring a circuit to it, and this is light. And this is my pit here. Inside the pit of the elevator, depending what type of elevator, you have to provide a GFCI receptacle for maintenance to maintain the equipment. We at the bottom of the elevator. Maybe we should take you guys to look at our elevator here, the one that we did installed new. Really, we'll take you there with Kiljic. You can see the GFCI receptacle. Why do you think a receptacle is there? Maintenance. Why do you think a light is there? Hello, you're going to be maintaining what? Are you going to be able to see? So they have a light there. So when you design, count on having these and throw a circuit to each one of them. 20 amp. I think you can put them at the same circuit, 20 amp, but I'm not sure. I have to review that one.
Is it 2.25 1.5 times full load current.
on the circuit breaker. Because I most likely is going to be a circuit breaker. Had it been a fuse, dual element time to the fuse, you'll do the same like the fuse. But I'm showing a circuit breaker. Most likely if it's in the panel, it's a circuit breaker. But if it's next to the elevator, as required by the elevator code, you have to have a fuse. You can't have a circuit breaker next to the elevator. Any question, guys, about the elevator? So next project, we will have an elevator. When you size it, Rob, exactly what you said. You're going to have a circuit breaker sized, the feeder, as well as the disconnect and the fuse next to it. The controller, we don't even mess with the controller. They have their own controller, guys. We just land our cables inside the controller. And they take it in the great state of Minnesota. They have two licensures. Rob, anybody knows that we license the people who do elevators? I mean, do you know what they call them? Gods. Constructor. They call them constructor. There are two licenses, guys. Master constructor, I believe, and journeyman constructor. So they give you like a journeyman electrician, master electrician. So in the state, we test and license people who install the elevators. So it's as an electrician, Ashley, your responsibility stops right at this point here. And with the elevator, all these bush pines that you push it down with it, the guys who install it, this is a funny story. They were actually in one of our schematic class, one of my schematic class here. So I get to know them. When their company came here, so they gave me a ride on the infrastructure. Everything that when you push these buttons right now, everything is Cat 5. All these push buttons that you see, when you push up and down, there is no multiple wires. All of them are daisy chain, Cat 5 in, Cat 5 out, Cat 5 in, Cat 5 out, all the way to all the floors down to the controller. All what they put in them is just Cat 5. And inside the controller there, it's programmable controller, and it controls all the ups and downs and safety factors inside that controller. So let me talk to Jeff Koldrick, see if I can get you guys a tour of the elevator, newly installed elevator, plus the boiler room and so forth. You haven't done that, right, Chris, last year with Gary? Okay.
He gave us, some of us, a short tour.
Short tour. Okay, would that be good, guys? Especially when I'm not here? Okay. So that's basically what I have for you. Talked about this one. Any question, guys, about this? Any question? Okay, you're going to hear Chad talk about this. So why don't you guys have a 5 minutes break and get back? And we are going to talk about, before you guys go on a break, how much do you know about clearances in front of equipment? Did we talk? We talked a little bit last quarter with Gary. Like if you have a switchgear, 4,000 amp switchgear, do you know how to assign a clearances in front of the switchgear for most part? Okay, that's what we're going to be reviewing. All right, 5 minutes break.